Hello everyone. Welcome to the Syed School. Today, we will learn about VLAN trunking between the switches. What are VLAN trunks? VLAN trunks, connecting multiple VLANs. VLAN trunks are network connections that allow multiple virtual local area networks, VLANs, to be carried over a single physical link. This is particularly useful in larger networks where multiple VLANs are in separate switches. Let's have a look at this network topology. We see two VLANs here, VLAN 1 and VLAN 2, on two separate switches. We need the devices on these switches to connect to devices on the other switch on the same VLAN. So, we use the same VLAN ports to create two links between the switches. Now devices on the same VLAN can communicate with each other. However, we use two links and four switch ports here. What if we make one trunk link and send the data with VLAN headers towards the other switch? This can spare two ports in this topology. We just need to configure a port as a trunk port in both the switches and connect them. The trunk link is created. In this topology, we can see that we have reduced a link and spared two ports. Trunk ports can be configured manually or can be automatically configured by the switch protocol. By default, some switches ports are set to dynamic auto mode. This is one of the modes of the switch port. This mode is passive and waits for a negotiation from the other side to get configured as trunk port. If we set the other port as dynamic desirable, then the automation of trunk port takes place. This mode desires for trunk link and starts the negotiation. Manually, we can set the port as trunk or access to avoid the negotiations. Types of switch ports. Access ports. Single VLAN. Access ports are configured to belong to a single VLAN. No trunking. They don't support trunking, meaning they cannot carry multiple VLANs on a single physical link. Trunk ports. Multiple VLANs. Trunk ports can carry multiple VLANs simultaneously. Tagged frames. They use tagged frames to identify the VLAN of each packet. VLAN negotiation. Trunk ports use protocols like DTP, Dynamic Trunking Protocol, to negotiate trunk configurations with neighboring switches. Dynamic Trunking Protocol, DTP. Dynamic Trunking Protocol, DTP, is a proprietary protocol developed by Cisco Systems that automates the process of configuring VLAN trunks between Cisco switches. It simplifies network administration by eliminating the need for manual configuration of trunk interfaces. Ports can negotiate if they should act as trunk ports. Ports can negotiate the type of encapsulation to be used for trunking. Administrative and operational modes of switch ports. Switch ports operate in two primary modes, administrative and operational. These modes determine the port's configuration and status. 1. Administrative mode. Configured state. This mode reflects the desired state of the port as configured by the network administrator. 2. Operational mode. Actual state. This mode reflects the port's current state based on the physical connection and network conditions. Administrative mode controls operational mode. If a port is administratively shut down, it will be operationally down regardless of physical connectivity. Administrative modes of a switch port. We configure it using the command switch port mode. Access. Always act as an access, non-trunk, port. Trunk. Always act as a trunk port. Dynamic desirable. Initiates negotiation messages and responds to negotiation messages to dynamically choose whether to start using trunking. Dynamic auto. Passively waits to receive trunk negotiation messages, at which point the switch will respond and negotiate whether to use trunking. We see a topology with two VLANs and a trunk link here. We need to configure the trunk link here, or at least make a situation where the ports start negotiation for the trunk ports. Let's go to the switch 1 now and check the interface status in enable mode. We see that the fast Ethernet port of the trunking link is not a trunk port yet, as VLAN status is not trunk, rather it is VLAN 1. Now, let's check the fast Ethernet port of the trunking link configuration in detail using this command. We see that the administrative mode is by default dynamic auto for this switch, which means that it does not start negotiation, which will be the same case for switch 2. So, no switch starts the negotiation for the trunk port and the port is in access mode. So, we see the operational mode as static access, which implies that the link sends the VLAN 1 data to the other switch. The administrative trunking encapsulation is .1Q by default, as we have not configured it yet. Operational encapsulation is the same. We see that the trunking negotiation is on and all trunking VLANs are allowed via this port. We can restrict some VLANs by configuration. We see voice VLAN here, which is used for the IP phones, which we will discuss in the later videos. Now, let's switch to the switch 2. We do the same analysis here. Now, let's go to the configuration mode to configure the trunking link port mode as dynamic desirable, which enables this port to start negotiation for the trunk ports. We configure fast Ethernet 0/0 in this case, and we'll use the command switch port mode. Now, we can see that once the command dynamic desirable starts negotiation, the trunking link port on both the switches are configured automatically as trunk ports. Now, all the devices on any VLANs on both the switches can communicate with each other via this trunk link. Now, let's ping host 3 and VLAN 2 from host 6 and VLAN 2 to check if they can communicate via trunk link. Let's ping the host 3 IP address and check the reply. We see the reply indicating that the devices in the VLAN 2 can communicate via trunk link now. Now, let's try to ping host 1 in the VLAN 1 from host 6 in the VLAN 2. We see that the devices in the different VLANs cannot communicate via trunk link. Now, let's ping the host 1 in the VLAN 1 from host 7 in the VLAN 1. We see that they can communicate. So, any devices with the same VLAN can communicate via the trunk link.